All right, I think we're live. Cool. So, hey everybody, John Bobrow here, creator of Blinks, and thanks again for joining for another one of our Blinks Lunch and Learns. Today I'm going to try something a little bit different. Normally we're doing games and we're playing games from the Blinks game system. And so if you've joined in today and you don't know what that is, definitely check it out. There's a link down to Blinks from our channel, and each of the Blinks are these intelligent game pieces that, normally we're playing some games on these. Today what we're going to do, instead of playing one of the existing 12 games, is I'm going to show what comes in the developer set and how to make your own games. And so this is the process we go through for developing our games, and it's a perfect time to ask questions about it. I'm going to leave this video up for developers to help go through the process as well. We're creating a lot of tools for our dev community, and the next hey, Jonathan West. Awesome. So glad you joined. I think Jonathan has a developer kit in hand. Yeah, so I think we want to make sure that it's real easy to make games for Blinks, and I think you'll see throughout this 30-minute video just how easy it is to get started with them. And yeah, I'm also going to be trying something new, which is I'm going to be doing some sharing of my computer screen, and we'll see how that works. And yeah, just if you have questions, throw them into the comments. And also if you just want to say hello, or if you're curious about some of the new games, we'll load up and show, because our games are open source, I can grab any one of the games in development and we can load them up on our Blinks. So let me start by showing what comes in a developer kit. Oh, and always, right before I get started, it would be silly not to mention a week from yesterday, so 6 days till we're launching our next Kickstarter campaign, April 29th. We'll be launching at 10 a.m. And so if you want to get in on the early bird rewards, that's the place to be. All right, so I'm going to switch cameras. Let's see how this goes. Game only. Yes, cool. And actually, let's do that. So, all right, so, Blinks, of course, you've got your sushi rolls of regular Blinks. The developer kits, mine doesn't have a cool, nice label like yours will arrive with, but the developer kits have gone through a couple of iterations. So I just wanted to pull out two of the latest ones that we've been shipping, and I'll point out the differences. Really, we've just been making tweaks to hopefully make things easier for everybody. So let me see. I'm also going to keep these comments in view. Oh, that's pretty close. Cool. Here we go. So in our developer kit, and so this is the bare bones dev kit, but if you ordered a 6-blink dev kit, you got the bare bones plus an additional 6 blinks. And so inside of our dev kit, there's a single blink without any, it doesn't have game art on the back. Some of yours might have, most of yours actually will have a blank, so you can write on that label. Similarly, if it doesn't have a sticker there, you can put your own sticker here, or you can draw with Sharpie. Sharpie works amazing on these. So awesome. Brian, I'm so glad you joined. Perfect timing. Very cool. So it's neat. We just had another like 60 or 70 developer kits shipped this past week. So let's see. So these are the blanks. They don't have games on them, or at least not yet. When you turn them on, they are going to do something different than any one of the original games. I think the sketch that's running on there right now is kind of a, the one that you'll receive is red, green, and blue, just to make sure that the lights work. All right, so I'm going to put this blink away. Okay, so we've got our blank. What else is in this developer kit? So I'm going to set aside the bag. There's a USB cable in there. Some of you might have a short USB A to B cable. Most of you now are receiving a 3-foot long cable, so it just gives you a little bit more room. The short ones are nice for my laptop, but I thought the 3-foot was a little bit more convenient for most cases. And then there's a programmer. So the programmer is the tool that connects to your computer to your blinks. And so that's this device. It could be this red board like this here, or I'm going to hold up a slightly different one. Some of the ones we shipped out have 3D printed enclosures. Since COVID started, we had to actually pull that part, mostly because we had to vacate our office, so we couldn't be printing the cases. Inside of there, you'll notice is the exact same thing. These two boards are identical. They're both programmers, whether it's black or red, works the same. And so I'm just, for sake of this video, going to use this red one. And there's one button on here, one switch, better yet. And that switch, when we shipped it, was set to power target. You're going to want to make sure that yours is set to power target, or most likely it's already, if it's working, it's set to power target. The last piece you need to know about on the dev tool is this guy. So, and I'm going to grab two different ones. So here we go. So this piece, I'll hold both of them up to the camera. So these two pieces, they're really identical. The only thing different about them is that there are different length pogo pins. And these pogo pins are what make the connection between the programmer and your blank. And so let me open up our blank. And so inside of the blank, you'll see that there are 6 dots, or 6 pins. Underneath all of the blinks are those 6 pins. The way the blinks are programmed is by placing those pins, those 6 pins, on those 6 holes. The short one is the one I've been using for years, and it works quite well. However, it doesn't allow you to see very well, if you're aligning it properly. I think it's a little bit trickier, is the feedback we were getting. And so with the latest set of developer kits, what I've done here is lengthened these pogo pins. And so when programming it, all you have to do is make sure those 6, you'll kind of feel them go into the holes. And then when it's aligned, it's real easy to see. And so you push down a little bit and those springs will move, but the board never gets flush with the blink. So you can hold it like this. I like this programmer too. Depending on which one you have, they'll both work. The ones we're shipping right now are the longer pogo pins. So I'm going to plug that on here. The cable comes off of the back of there, so everything should just kind of look the way I have it here. And then I'm going to go ahead and and there's 2 more items in our bag, so I should cover those too. This one, if you hold your camera up to the QR code, it'll take you to this website, move38.com. Let's do this. And I'm going to go there right now and show you what's there. So let's see. Here we are in browser. So cool. All right, so move38.com. Let's do this. All right, so this website is our Blinks Dev landing page. It's got 3 quick steps to get you up and running. And the first of which is that you should join our forum. If you have a developer kit and you haven't joined our forum, you definitely should. It's the place where you can post what you're working on, see what others are working on. We've had a lot of activity and actually have sourced some of our community set games, the next games we're launching, from games that were shared in the forum. So the forum's the place to be. You can click on that yourself and check that out. The next thing is you need to make sure that you install Arduino. So Arduino is kind of like a text editor, but with a button to allow you to upload your game to Blinks. Arduino is the most popular beginner hardware development platform. It's in millions of homes around the world, and the ease of use for Arduino has made it so that a lot of people can make their own stuff with hardware. Blinks, every single Blink. Actually, I want to come back to, let's see, the view where I get also my head. Cool. So I should point out that every single Blink is itself, every one of these, is an Arduino. And with everything going on in the world right now, I had this thought that, like, oh man, it'd be a really beautiful thing if, you know, all of the kind of electronics we had were so easily repurposable. And Blinks, in all honesty, in any sort of situation, could be used for something else. You could use the controller inside of a Blink to control something else. And I'm not going to cover that so much on this first developer livecast, but there's also some really neat, one simple example Josh, our tech lead, loves to point out is he's like, you want your Blink to turn on your TV? It'll turn on your TV. If you want your Blink to turn off TVs, maybe that's more appropriate, you can make your Blinks turn off TVs. So Arduino is the development environment we're going to be using. And the third step on here is to download the SDK. And so I'm actually, I guess I should do that on screen. I'm trying to think the easiest way to, I may actually skip past that step. We'll definitely record that in video so it's nice and obvious, but by clicking on Blink's SDK, it downloads a folder, and that folder gets placed in your Documents folder, and it allows Arduino to recognize Blinks rather than just Arduinos. The last thing on this page is that we've got some tutorials. And those tutorials, let's see if I can scroll that a little bit better. Those tutorials walk through making Blinks do the very basic things that you'd want to start out doing before even making a game. And we'll just hop right into it. So let's see, I'm also going to check the comments in here. Let's see. Waiting until it's darker to open it. Awesome, yeah, Blinks at night are definitely the way to play. So let's see. Oh, question about the MCU. So inside of each Blink is a Atmega 168 PB. I'll put that here. Mega 168. And yeah, if you're really savvy with electronics, you can look up the data sheet and understand exactly how we're using that controller. So that means it has 16 kilobytes of memory, and our Blinks OS uses about 2 kilobytes, and then we split the space of the rest of the chip to for games. Half of that is set aside for the game. Oh, and actually, let me switch to my end. So half of the space on Blinks is reserved for the game that you're teaching, that you are programming onto it, and then the other half of that space is the game that it's going to actively play. And so when it's playing its own game, it actually just copies itself over into that memory and just runs the game right from there. So let me get Arduino up. Cool. And then I'm going to switch my screen to Arduino. All right, cool. Oh, and there's like a little green outline. I might be able to get my head on screen too. Let's actually try that real quickly. Um, learning as I go. Video capture, yes. Built-in eyesight, okay. Cool. That's handy. All right, cool. Now I'm there too. So let's try this out. So when you're programming blinks, you're going to need to go to the Tools drop-down and select the kind of board, and it'll be Move 38 Blink is the kind of board. Let's see. And once you do that, you'll notice that like the examples folder is populated with some blinks examples at the bottom. We're not going to break out the blinks examples. We're just going to use my knowledge of the blinks library to create some really simple interactions. So the first thing we're going to do here is notice that setup, it calls out what it does. It says code put here only runs once. And what that means is when you put the battery in your blink, setup is what happens. So let's actually see that happen. So set color red. So if we put that there, I'm going to plug in my programmer. There we go. And I'm going to hold up so we can see. We know the programmer's plugged in and working because the lights are on. I'm then going to hold that up to my blink, and if it's working correctly, let's see. I will put that on the back and I press upload. And when I'm uploading, it'll just say compiling. And then actually I can probably bring this in view as well. There we go. So at the bottom, if you put verbose mode on, you can actually see the process of it uploading. And cool, it's done loading. And now I just need to, you can see it was powered on by the cable, but I'll put a battery in there. So we just uploaded that sketch, and sure enough, when we put the battery in, the blink glows red. So no battery in, I put the battery in, and the blink glows red. So all I needed to do was call that once for it to happen, but since we're not putting the battery in and taking it out, at least not often at all, we're not really gonna, if you take a look at the code for all of our games, I think almost all of our games leave setup totally blank. So I'm gonna move that out of setup, and instead we're gonna work in loop. And so loop is the thing that's happening, let's say for the sake of our video, roughly 30 times a second. It might be a little bit less than that, but it's the equivalent of a frame rate. Loop actually can happen a lot faster than that, but for the kind of gameplay stuff we're going to do, we'll treat it as though it's happening like the frame rate. Cool. Yes, I see Brian's asking about an STL somewhere for the programmer case. Oh, yeah, I'll put that up on Thingiverse, and you can print your own. That's a great idea. I'll link it on Thingiverse. Yeah, I love the, like, I have to say, the coolest thing about the world we live in today is like the ability for me to post a 3D model and then for you to make your own cases for your blinks and things like that. So yeah, happy to put those up. So let's do something a little bit more complicated. So let's use an if statement. So what are some of the conditions that we can think about with blinks? Well, blinks have a button. The button can be down, it can be pressed, it can be double-clicked, single-clicked, multi-clicked. And so all of those are keywords in blinks. And so if I say button down, if button down, you notice that the words button down, when I complete typing it, they get colored like that to show you this is something that the system understands. So if button down, we're going to say set color blue, else set color red. And this isn't going to be a heavy coding tutorial, but it's difficult for me not to, so I like to use these brackets whenever I use if-else statements, so everything inside of here will execute, everything inside of here. Sometimes you'll see in code the brackets aren't there, which means only the line after the if statement is going to execute with that if statement. So we can press that check mark and see if our code compiles. It does. And you'll also see here that it tells us how much space our sketch uses. So the bare minimum sketch uses just about this. The number actually, if I delete these things, might change a little bit. Let's see. So if I delete what I have there and compile, it's a little bit higher. I honestly can't explain why that is super clearly, except that I know that the compiler, depending on how it's going to arrange the code, and remember, it's compiling our OS in here too, will use more or less space. So it looks like, it oddly looks like this simple application that we just wrote uses less space than a blank sketch. Cool. So let's go ahead and load that on a blink. I'm just going to press the pins on there. It's pretty easy to do one-handed. I know that there's a little bit of a learning curve, but just keeping that pressure on there. Let's see. Cool. All right, so program that. One other thing I really like, it's not so much fun to be pulling the battery in and out, but to make it easier, you can attach, because the batteries are magnetic, you can just flip it over to the side of the blink and then just pop it back in. So in this sketch, it said if button down, blue, else red. And you can see every time I press the button, whenever it's down, it goes blue. And then, that's actually a good thing to show. So let's see. So the button, so it's showing red and it's showing blue. If I hold the blink down for 3 seconds alone, it goes into that search for program mode. That's part of our operating system. So to get rid of that, you'd have to program at a lower level. Really, we don't want you getting rid of that when you're making games for blinks, because that's how it teaches all the other blinks. So this is a good time to show why this is really cool. So programming one blink is pretty neat, but I'm going to switch over to here. So programming for one blink is pretty neat, but having to do that to all your blinks would be such a pain. And we know because we did it for years. Then once we taught blinks to teach each other, it made this whole programming blinks a lot more fun. So now the sketch that I've taught this blink, this one that I have programmed, if I want all the others to behave the same way and run my code, they're all learning it right now. And it'll happen pretty quickly because it's not that big of a sketch. And so now all of these are running exactly the same code. So all of these blinks, and you can walk away with them. Remember, they'll remember this until they get reprogrammed to know a different game. So now I've got a whole bunch of blinks that turn blue on button down. Lee asks, will I be releasing the STL file for the programming jig? Yeah, I can post that online as well. I'd also like some help making a new programming jig, something to make this a little bit easier. I've had some thoughts about something with just using metal. Oh, whoops. Well, too late to turn off. either way, I think there's a nice way of setting up a programming jig for the new programmers. The old developer blinks have like a nice little magnetic tool that allows you to kind of almost no-handed program blinks. So I guess the short answer to that question, Lee, is yeah, I'll happily post and share anything we've created. And let's see. So I'm going to switch back to our screen. And actually, let me take a quick look at our questions just in case. Cool. I'm going to forge ahead. So one of the things that I'm going to share here is like programming for blinks is really really limited, but I think in a very good way. So if we look at, let me see, where's our, oh, maybe I don't have it on here. I should. It's the kind of thing you would think I would include. We should have a nice list of all the functions that you might need. So let me try this. Cool. So here's a little cheat sheet I have. So this cheat sheet shows all the things I can do with blinks. And so all the things I can do. So we've used set color. We have not yet used set color on face, and I'll show that in a moment. That lights up one of the lights on one of the 6 faces. You can make your own colors, or you can use ones that we've predefined. The buttons, these are all the things you can do with the buttons. You might notice we only have button down here. If you want it to be, if you want to do something on button up, which is just the regular state of the button, you can do if not button down. The next thing I want to show, let's see, sorry, I'm going to stretch that a little bit. So the next thing I want to show is communication, because it's the most important thing about blinks. Timers are really handy. It's how we do things that happen on a set time. But communication, I would say, is like where you really get into the interesting properties of blinks. And so let's see. So I'm just going to use some of these functions. This is everything. This is everything you need to know to program blinks. It's not a lot. And so let me go ahead and come back to, all right, here we go. So I'm just going to stretch this down, and we're going to let a blink communicate. How about if it's buttons down? I mean, I feel like that's a nice next step. So the communication for blinks is set value sent on, and in this case, I'm going to say all faces. And so what this means is it's going to broadcast on all 6 of its faces a value. And so by default, it broadcasts the value 0. So we're going to use a value other than 0. So how about we say if it's blue, we're going to send the number 1. And if it's red, we're going to send the number 2. And so by default, this blink is now going to be broadcasting the number 2 on all faces. And if we push the button down, it's going to change that to the number 1. So now we've got the blink sending stuff, but we aren't checking anywhere. Remember, this blink is running the exact same code as the blink next to it. So we need to have some code to look for these messages. So let's go ahead and do this. So we're gonna, this is a comment, look for values coming in on all faces. So we're gonna use, I'm gonna show something in 2 ways. So you're probably common with familiar with something that looks like this. And that's a for loop. It's going to increment the variable I from 0 to, in this case, 5. In this case, 6. Let's see. So if it's less than 5, then it will increment. It'll go through this loop. And also, just to make that a little bit more legible, I could do, if it's less than and equal than 6, it will increment. Or less than or equal to 5. So to go through all of the faces, I could have a loop like this. Because we use these so commonly, we created one for each face, in which case the variable f, or whatever variable I put here, so I could say face, is going to iterate through 0 through 5. So now I'm going to look at each of my faces. So I'm going to say if get, let's see. Oh, this is actually perfect. I have to reference it. So it's, is value received on face expired? Okay, so I'm going to switch back here. So is value received on face expired? And so what we're saying there is, essentially, when's the last time I've seen that value? I might have received a value on that face, but then I took the blink away, and now that value's expired. So this is saying, is a blink on this face? And we need to pass it, because I'm saying on face, we need to pass it a value. So we're going to pass it face. How about, if so, we're just going to say set color white. So this is, if a value is received on face, set color white. And actually, you know what? Let's do this. Set color on face white, and we'll pass it the face. Cool. So I'm going to compile that, make sure it works. Cool. And I'm going to shorten that window a little bit so you can see what that looks like. Okay. And so when I compile that, awesome, you can see that the sketch uses a little bit more space. So we're starting to write code. It takes up a little bit more space. We're only using 31% of the program storage space. We're pretty much at 30 when we start anyway, so your games can be quite long. So I'm going to upload that sketch. Press upload. I'm holding the programmer to my blink. It's writing. It reads to make sure it wrote correctly. Okay. So I actually think I may have a bug in here. So when I power it on, it's all white, which is kind of suspicious. That suggests it's received some value on faces. So let's see what we could be doing wrong. Is value received on face? Oh, what an easy thing. Did anybody catch what I did wrong? Of course, all faces are white. The values on all faces are expired. We haven't received anything. So I need to say, if the value is not expired, go white. So, cool. I just corrected that. I re-upload. Oops. Here we go. And so I'm uploading the new code. And one of the things, I think there's many ways to program. You can kind of write out exactly what you want to make ahead of time, make sure it works, and then upload it. I'm a lot more loose and fast than that. I like to kind of upload something. So here our code's working. It goes red, blue. And then I said, let's see. I said, if it's sees a neighbor, haha, do you see that? So on the face that's connected, it's glowing white. So it's confirming to us that this blink is aware of its neighboring blink. So that's pretty cool. But we're not using any of the information we're sending yet. We're just responding to the fact that it's got a neighbor there. So let's do this. So inside of this, once I know a neighbor's there, I want to get the value. Value, let's see. So I think it's get last value received on face. Get last value received on face, yes. And we named them kind of, it's a little bit lengthy, but it's exactly what it is. On face. Face. And so that's going to return a value. So if it equals 1, then I want to do something. So how about we set color on face. Oh, how about let's do this. Let's just set color, and we'll make it like make color RGB. Let's make it something nice and beautiful, like a really nice like blue-green. So 0R, we'll do, let's put like some green in there, maybe half of our green. And then we'll do all of our blue. So set color, and then else if, I'm just going to bring this back down so we have a little bit more room to code. I had you worried you're using the function wrong. Yeah, sometimes I have myself worried that way. Luckily we're it's all up and running properly. Yeah, all of our games are using this exact API. So else if, we're going to, okay, so we're going to have a couple of these. Looks like I've got one too many of those in there. Cool. So if, oh no, that was correct. I think that's right. Oh wait. Else if, so this one goes here. If that, else if. Yeah. And then we want another else on there. That looks right. Cool. That goes to that, that goes to that, that goes there. Okay. Still looks like we're missing one. Nope. Maybe we've got one too many. So what I want to do here is else if, oh, that's why it's funking out. So if, I'm going to, in this if statement, say if get last value received on face equals 2. And so remember, up here we're saying if the button's down, it's going to send 1. If the button's up, it's going to send 2. So let's see. So if the button's down, it's going to send 1, and we're going to be that beautiful color. And then if the button's up, we're going to make it another color. And how about when the button's up, we use this set color white on face. And I was getting a little fancy with this else over here. We don't need it. So there we go. That looks right. Cool. So that compiles. And let's load that up and see what I just made. Okay, so I'm going to press upload. Cool, it's all uploaded. Press my battery into place. And on this one, I'm I can't really test that receiving function until I load it onto another one. So I'm going to load that onto all my blinks, and we'll take a look at what we made. So go ahead and switch to this scene. So I've programmed this one. I'm going to have it teach the others. All right. And this is the way we iterate all of our game animations. There are some, sometimes when we're going to be changing small variables and things like that, we try and create tools to make it nice and quick. So maybe I'll use a multi-click to change the duration of a variable that I'm trying to test multiple durations. So our blinks all loaded up. Cool, and that's very promising already. So they're red if the button's up, if it's not down. When they connect to each other, we can see that they light up white on the face that they connect. And then here's the real test. If I press this button, yeah, cool. So when I push down, the ones neighboring show that really beautiful green-blue. And now I've got this kind of cool button pad. So, cool. So that's our, we haven't made a game yet, although I think one of the neatest things about programming with blinks is trying out interactions that you want to see and then trying to make them happen. Let me actually check my schedule to see if I can take this stream a little bit longer, and we'll leave it up for those of you who can't continue to join. Let's see. Okay, next on my calendar is walking Ernie. Ernie? I think he's okay. All right, so I'm actually going to try and do something here, and we'll see how quickly we can knock this out. So I'm going to switch to, here we go. All right, so a friend of mine asked me if we had made like a tic-tac-toe before, and we haven't really done that before. So let's see how I would go about that. So I might want to create like a enum for the states, which is tic-tac-toe. And so essentially that means, really I'm just saying that equals 0. Oh, tic-tac-toe, we don't need 3. X spot equals 0. Let's, yeah. And then I need a comma here. And we'll call this an O spot. Cool. And so in this case, we're going to say x's are 0. And actually, we can be specific about this. Let's get out of that 0 range, because as I mentioned, by default, we broadcast 0. For x's, 2 for o's. All right. All right, so let's go ahead and do this and say that Boolean is x. And we'll start that off by saying, yeah, let's start it as an x. Cool. And I'm going to jump around here, so I'm going to erase all this code. Well, actually, let's not erase that yet because we've got communication already built. So I'm going to say, I'm going to create a function called display x. And display O. And these two functions are going to be just a nice, easy way for us to set display, or sorry, set color off. And then we're gonna for an X, let's just make like 2 of the or 4 of the faces light up. So set color on face, and we'll make an X. We'll make it white on 0. And 1, and then 3 and 4. So that's going to be our X. And then for our O, feels like our O's should probably have all of them. But we're going to do something fancy, which is we're just going to say we're just going to rotate 1 around. So we're going to move this 1 around, and we're going to say millis. So that's the milliseconds that have passed, divided by how often we want it to switch. So let's say that. And then I'm going to mod 6. Cool. So now it's going to just rotate around on the faces when we call display O. So those are our displays, and we're going to want to say if equals not is X, and we're going to send the value O spot in that case. Here we're going to send X spot, because it is an X. Oh, no. If is X. Oh yeah, this is real messy. Okay. So, I'm going to work on my live coding skills. So, if it is X, we're going to set the value sent on all faces to be X. We don't need this down here. Okay. But we do need that button pressed. Okay, cool. So this works. Well, every time the button's pressed, we're going to change. If we're an X, we're going to become not an X, and we're going to update to send O on our faces. If we're an X, we're going to send X on our faces, and we only need to set that once, because it will continue to broadcast that value over and over again. Cool. So now we have a blink that will send which face it is, and it's going to start out as an X. Let's comment out our listening here. Awesome. So I'm going to comment that out, and let's see, bool. Let's see, what did I do wrong about our bool? Oh, I need a semicolon there. So after our enum, I needed a semicolon. There we go. Cool. So I'm going to go ahead and load this up, and we just want to see if our code functions to display X and O correctly. Oh, except we're sending X and O. We were never calling those display X and O. Oh, and I just got a battery warning on my laptop. Cool, so I'm going to be real fast. So down here, I'm going to have to add if is X. And actually, we don't need to call it multiple times. Let's just display it. Display. Oh, but our Y animates, so we need to display it over and over again. If is X. Display X. Else. Display Y. Oh. Cool. That compiles. I'm going to load that up. I'm going to press upload. Awesome. I've got some strong support on the live coding thing. It's going to go better and better each time. So here we go. So when I turn it on, oh, it's a little bit difficult to see, but there we go. That's the X. And then if I press the button, it switches to an O. Cool. So that's an O, and that's an X. It's maybe not totally fair that I gave an O an animation and an X doesn't have an animation. So let's see. Let's give the millis divided by 500. Let's go ahead and give the O, or the X, also an animation. So we'll do this, and I'll say else, and we're just gonna do, so I think we'll get a little bit of like a, let's see, we'll set the other ones on. So we'll do, which ones are we not turning on? 2 and 6. Cool. So now we've got an X and an O that animate. That feels more fair. Okay. So now we want to know about the X's and O's we're next to. And I'm going to uncomment. So we're already listening for these. We're already listening on our faces. So I want to know, am I next to an X spot? Or am I next to an O spot? And by using these enums up here, it makes it a little bit easier for us to then look at our code later and go, oh, okay, I'm setting the value to an X spot rather than just using a value 1. So let's see. So this is, I am next to an X. Cool. Let's see. And so I'm next to an X. Great. And I'm actually just going to write the pseudocode in here. Cool. If I am an X, and if I have another X on my opposite side, I win. Right? So like in Tic-Tac-Toe, if I have an X on opposite sides of me, I know I win. Else, if I'm an O, I'll want to do the same thing, but for O's. If I'm an O, and I have another O on my opposite side, I win. Cool. The code we'd write there would just be another if statement, and then we can animate the one that knows it's won, or we can tell our neighbors, hey, this is the game that won, and yeah. So let me just load up some X's and O's on our blinks, and we'll end with the animation, and then we'll come back, and if this is something that everybody enjoys for the live coding, we'll definitely try it, and we'll try and do it with also some of the things that you might be curious about as well. So, oh, and I need to make sure that that's a comment. Cool. Thanks for joining me for this coding session. This is definitely a first. Next Tuesday, we'll be returning to playing some of the games, and you'll be able to tune in to play the games with us. So let me just switch for our last bit here. So I'm going to load our X's and O's. We don't really have Tic-Tac-Toe just yet, so just going to load X's and O's up here. We'll see what this looks like. Cool. And as I've got like 3 more minutes, it's a good time to say that if you've got your blinks in hand and you're playing games, we launched a competition this morning. And that competition, oh, that's kind of cool. Okay, so these are X's. And the competition is to post you playing with your blinks and hashtag Blinks Recess. And we're going to select 10 winners, people who post Blinks Recess posts with photos of them playing blinks or fan art. And 10 of those people are going to receive our some of our community set games. 3 lucky winners are going to get all 6 of the community set games. So definitely participate there. Let me change some of these to O's. Cool. So we've got 3 O's over here, and all 4 of these are X's. I'm clearly going to have to work on how Tic-Tac-Toe reads on this. This is a pretty loose start. Let's see. Well, thanks so much for joining. I had a really good time. Maybe I'll take this and run with it. I'll post those STLs in the forum and in the YouTube as well. And be sure to subscribe if you haven't down below. And looking forward to seeing you next Tuesday. And be sure to get the word out for our Kickstarter launching April 29th, next Wednesday. Can't wait to launch our next games for Blinks. And if you want to get a hold of Blinks right now, get them at move38.com. Peace.